Hi there, my name is William Garman, and today I'd like to show you something I developed as part of my BSc Computer Science degree's Graphics for Games module. Our job was to create 6 different shaders that we could use to destroy a cube in their graphics framework NCLGL. I used OpenGL's Vertex, Fragment, Tessellation, and Geometry shaders to do this. While in each of the scenes the cube is destroyed in a different way, the shaders used for it share quite a few similarities. For example, every shader takes in time as a uniform because each of the scenes involves the cube being destroyed over time. First off, I'll show you the 3 simple scenes that already have their method of destruction specified. Now, they're a lot less complex than the more advanced scenes because they only use the vertex and fragment shaders. The first of those scenes is the shrinking scene, which basically does what it says in the tin. The vertexes of the cube slowly shrink towards its center. This is done in the vertex shader by altering the GL position of each vertex to be closer to 0 over time. As you can see, the cube eventually shrinks to the point of disappearing. The moving rainbows you can see on the surface of the cube are the result of a fragment shader which is used for all but one of the scenes in the project. It bases the RGB values of the fragment on how close it is to the top point of the cube as well as the current time. The only scene that doesn't use this shader is the 2 texture scene, which is up next. As the name suggests, the 2 texture shader takes in 2 textures as uniforms. One is the clean or non-damaged texture and the other is the damaged or destroyed texture. It's supposed to represent the cube being destroyed by slowly interpolating from the clean texture to the destroyed one. As you can see, for the clean texture I used a mud/dirt texture, and then I took a similar texture that looked more dried and cracked, and used it as the damaged texture, so it looks like the cube is drying out and cracking. Last of the basic shaders is the transparency shader, the goal of which is to slowly turn the cube transparent until it completely disappears. I used a similar system to the rainbow fragment shader to make it disappear from the top to the bottom, because I thought this looked better than it simply fading away. 2 key differences between it and the rainbow fragment shader, however, are that it operates on the alpha value instead of the RGB ones, so it changes the opacity. And also, it doesn't loop, it goes transparent and stays that way, unlike the rainbow fragment shader that feeds its time and position into a sine function so it always loops around. Now that I've shown you the 3 basic shaders, I can show you the more advanced ones. Each of them uses a tessellation shader to divide the triangle primitives of the cube up into smaller triangle primitives, and then a geometry shader to then alter or move those new triangle primitives. Unlike the basic shaders, we didn't have what we were supposed to do already specified. It was up to us how we were going to destroy the cube as long as we used the advanced features to do it. The 3 scenes I ended up coming up with are the shatter scene, the falling apart scene, and the meteorite scene. I'm going to start by showing you the meteorite scene. This scene involves the cube being impacted by another cube that's meant to be a meteorite and leaving a massive crater in it. I did this by tessellating the cube and then using a geometry shader to move the new vertexes towards the center of the cube based on how far away they were from the impact point. The impact point is set within the shader, and the meteorite is simply a separate object that's programmed to move in to hit the cube at that exact moment. Next up is the shatter shader. It tessellates the cube again, and then after a certain point the geometry shader projects each of the smaller triangle primitives away from the center of the cube, basically scattering the fragments. It does this by finding the center point of each of the fragments, and then projecting them along the vector between the center point and the middle of the cube. You may have noticed as a small detail I changed the rainbow wave fragment shader so that after the shattering of the cube the colours stop actually shifting as a kind of more of a sign that it's broken. Lastly, I'm going to show you my personal favourite, the falling apart scene. As you can see, from top to bottom the cube slowly dissolves into small cubes. Similar to the shatter scene, it tessellates the cube and then finds the center point of each of the new triangle primitives. It dissolves the cube in a wave by using the center point's proximity to the top of the cube to calculate if and how far it should have fallen by this point. If the primitive should have started falling by this point, then it disregards the old vertexes and instead emits a triangle strip primitive that's in the shape of a cube. Well, that's the end of the demonstration. I hope you enjoyed watching it. I definitely enjoyed this project and it's made me interested in doing a bit more graphics programming work in the future. Thanks for watching. Bye.